FOIL method. So this is just another way to talk about doing that distribution. So I'm actually going to go and do two methods here at the same time. So FOIL method, we use, if we have two binomials, so AB and CD, what we're going to do to multiply them together, so I'm saying I have something like this, AB times CD, is that we are going to first multiply your first term. So as we see down here in the little picture, it's showing me that these two terms are my first. So it means the first in each binomial. So we're going to do those first. Then the next part, we're going to do the outer. So it's going to be the A and the B. So it's the outermost numbers that we have, or terms that we have. Then we are going to do our inners. So it's the innermost two terms that we have. It's hard to see, but that's an I there. And then the last part we're going to do is going to be the last term in each one of these binomials. That's how we get FOIL, because it's first, outer, inner, last. But excellent, put the solution on here. So let me just get rid of that for a second. Or my slides are out of order. So I want to multiply these two binomials together. If I do FOIL, if I do my first term together, what they're saying is it's going to be this x and that x. They're the first one in each one of my polynomials. So my first is going to be the x times x. Then I'm going to do my outers. The outers would end up being this term and this term, because they're the outermost terms. So it'd be the x and the 6. You might be noticing it's kind of another method going along with this. Then we are going to do the inners. The inners would be these two terms here, because they're the innermost ones. So that would be the -4 and the x. And then we want to do the last two terms. So that would be this 4 and this 6 are my last two terms in each polynomial. So the -4 and the 6. So what we have is x squared plus 6x minus 4x minus 24, or x squared plus 2x minus 24. FOIL just does that distribution for us without having to go through and distribute and then do that second distribution. But if you notice with my arrows, what FOIL is really trying to do is make sure that you multiply all your possible pairs together. So it's like a mnemonic device to make sure you don't miss anything. Because what I did was this. I multiplied this term to this term. So I've married that pairing. Then I take that x and I multiply this term. I'll take that x and I pair it to both terms in the other polynomial. Then I take this 4 and I pair it once again to each term in the other polynomial. So what FOIL is trying to do is just make sure that we do all these pairings. So what I'm doing with the lines is what we call umbrella method. So if you go back to your worksheet, without having to do the way we did it before, which was like two distributions, we can use that same idea here. All it is I'm taking this term and I'm making sure that I match it to everything in the other polynomial. And then I do the same thing with the next term. is I make sure I match it everything. So I get all my possible matches that can happen here. You don't necessarily have to sit there and sit and think through your like foil going, I have to do the first together, the outer together, the last. You can just use the umbrellas to make sure you pair everything. So I take that last term and I make sure it matches everything. Well, hopefully you didn't hear that loud noise. I have no idea what it was. I think it's possible that I made an error in the last one I did this. We'll see here in a second. Yeah, I think I accidentally left that a 5 last time, and that was a 15. 5x to the 5th. So that should actually be 16x to the 5th, not 6x to the, or 16x to the 4th, not 6x to the 4th, I think is what I said. I made a typo. Like I said, you could just use that umbrella method and do this instead. You just want to need to make sure you do all your possible pairings. So for number 5, multiply these. So you can just do your umbrellas, or you can sit there through foil and go, I need to do my first ones, my outer ones, my inner ones, or my last ones, but just go through and multiply this polynomial. Whatever method works, as long as you get the correct answer. Okay. So I'm going to do my umbrellas, but I'm going to still do foil with it. So I need to make sure I pair these two terms together, which are my first. So I need my 3x and my 5x. Then I need to make sure the 3x matches with the other term in the other polynomial. So I get a 3x times 8y. Then I'm going to do this with this term here. So I'm going to match that y to that 5x. So I get y times 5x. And then I'm going to match this y with this 8y. So I get y times 8y. So I get 15x squared plus 24, so my brain shut down for a second, xy plus 5xy plus 8y squared. So if that's simplified, that is 15y squared plus 29xy. Those are like terms, plus 8y squared. So the last bit of multiplying polynomials is going to be doing a square of a binomial, and then we're going to do the product and the sum of or a product of a sum and a difference. That's going to involve binomials too. So we're really looking at what are going to be some special cases. And part of the reason we're doing this is because not necessarily because we're going to go this direction with these special cases, but eventually we kind of use them to go backwards. That's what we call factoring. So square of a binomial. So if I have a binomial, a plus b, and I square it, if I square that, this is a plus b times a plus b. And if I do my FOIL, I get a times a, so a squared, a times b, so a times ab, b times a, which is still ab, and b times b, which is b squared. So to simplify that, that is a squared plus 2, I got 2 ab's, plus b squared. So that is where this comes from. And if I did this with a difference, a minus b squared, then we're going to get a minus b times a minus b, which is going to be a squared minus ab minus AB plus b squared. Because remember that negative b and that negative b together will turn into a positive. Bump something on the screen there. So we're going to get a squared minus 2ab plus b squared. That is where this part comes from as well. Okay, so this next part might be a little silly. Let's say we wanted to multiply this together. There's no reason that you can't take this and just do a FOIL. There's not really a lot you from doing that. However, I just kind of want to encourage you to kind of use using some formulas and identifying them. So if I have a plus b squared, and I know that if I FOIL this, expand it, we're going to get a squared plus 2ab plus b squared. And what we're given is m plus 7 squared. So what we're saying here is that a is essentially m and b is 7. So instead of having to do all this work of expanding this and doing the distribution or your FOIL, you just easily look at this and go, okay, well, m is my a, so I'm going to have m squared plus 2 times a, which is m, b, which is going to be the 7 times 7 plus 7 squared, or m squared plus 14m plus 49. So partly we use this as like a quick recognition of how I can rewrite something, so I don't have to go through all this work of actually doing the expansion and the multiplication. If you know that a square binomial, what it's basically going to look like, you can kind of cut to the chase and cut out some work for you. So take a moment on this one. So this is the other case. This is a minus b squared. And just try the same thing. So try to use the formula. Like I said, you can do it the other way where you can just go say 2x minus 3x y squared times 2x minus 3x y squared and just do an expansion, or like I said, multiply it. But try to use the formula for this one just for practice. Okay, so once again, we're saying that a is basically 2x because it pairs here, and that my b is going to be the 3xy squared. So we have a minus b, or 2x minus 3xy squared, and we're taking the square of those. What we should expand into is we get a squared, 2x squared, minus 2 times a, which is 2x, and b, which is 3xy squared, plus b squared, which is 3xy squared. So just remember with your rules of exponents, the square distributes. So that is 2 squared, x squared. And then here we're going to have minus, let me see, 4 times 3. So that will be 12. We get x squared, y squared. And this is going to be plus 3 squared because we're distributing x squared. And that will be y to the 4th. This is just 4x squared minus 12 x squared y squared plus 9 x squared y to the 4th. Okay, and this is definitely going to come back for us. So this is the product of a sum and a difference. We have a plus b, so that is going to be my sum. And then we have a minus b, and that's going to be my difference. So that's what we're talking about. So this is the sum of a and b. This is the subtracted, so it's the difference. But another term for these is that these are conjugates. So they're conjugates of each other. And there's a lot of places that we use conjugates because what we see here is that if I have a plus b times a minus b, what I should be left with is a squared minus b squared. So let me just quickly show you why that works. If I was to do my distribution here, we get a times a, so a squared. We get a times negative b, so minus ab. Now we have plus a times plus b, so positive ab. And then we're going to have b times negative b, so negative b squared. So the negative ab and the positive ab cancel out, just leaving me with the difference of the squares. So this part, as we see here, is called the difference of squares. Because of the squaring property, this helps us in certain problems. Like one of the cases, if we had square roots, we like to use conjugates because it gives us this difference of squares. We also see this with complex numbers. So the product and the sum of the product of the sum and the difference of the same two terms is going to be the square of the first term minus the square of the second term. So this one's a lot easier to remember, and I see a lot of people use this one a lot more than the previous. For example, like I said, if I went through and I did my FOIL or my distribution, I'm going to have y squared minus 8y plus 8y minus 64. So I'd just be left with y squared minus 64. If I do this with the formula, a plus b, a minus b, we know it's going to be a squared minus b squared. So we have y plus 8, y minus 8. So my a is going to be my y, and my b is going to be my 8. So it matches. That means I'm just left with y squared minus 8 squared, or y squared minus 64. We're going to give you one more example of this. So your last problem right here is going to be to multiply 3mn plus x squared to 3mn minus x squared. And like I said, try to use the formula for this to get your answer. Okay, so what math is we got an a plus b and a minus b. So my a is my 3mn because that's the term, and my b is going to be the x squared. So if I have 3mn plus x squared, 3mn minus x squared, then all I'm going to have is the 3mn squared minus the x squared squared. So once again, remember you distribute that power through. So that's 3 squared, m squared, n squared minus x to the fourth now. So that's just 9 m squared, n squared minus x to the fourth.